Today we're going to be working on Leetcode question number 18 for sum. We have done similar questions in the past. So basically we are looking for a unique quadruplets so that they need to be distinct and their sum needs to be exactly equal to the target. So if we have in this example we need the output is basically gonna be it's gonna basically it has to be uh, four distinct characters, four distinct values. So we are gonna sort the input array as the solution we are trying to achieve is O of n square. So sorting them is just gonna be n log of n, and initially our result is gonna be an empty array. And so then our first we're gonna have the first loop iterating through the nums. So I is gonna iterate from 0 to the length of nums minus 2. Actually in this case, sorry, we are doing the 4 sum, so it's gonna be minus 3. We're gonna have a similar loop iterating from I plus 1 to one element more than where the I goes. So it's gonna be nums dot length minus 2, and that's gonna be our second iterator. Then we're gonna calculate the low, which is gonna be j plus 1, and the high, which is gonna be the last element. As this is a sorted array, we can't miss um, the solution. So basically we're gonna keep doing it while the low is less than high. We're gonna calculate the sum, which is gonna be the values on all these four indices: I, j, low, and high. Then we're gonna say that if the target is exactly equal to the sum, so we're gonna put these four values I, j, low, and high to the result. Once we did that, we want to make sure that we don't want to use the same, because they need to be unique. So as long as the nums of low is equal to the nums of low plus 1, we're going to keep incrementing that. As long as the nums of high is equal to the nums of high minus 1, we're going to keep decrementing that. Then we're going to increment the low, and we're going to decrement the high. The other two things is, what if the target is less than or the sum is less than the target. If the sum is less than the target, we need a bigger sum, so we're going to increment the low. Otherwise we need a lower sum, so we're going to decrement the high. Once we are done with that, we also want to make sure, just because we are looking for the distinct like a unique solution, so we're gonna say that while the nums of j is equal to like the nums of j plus 1, we're gonna keep incrementing j, and similarly we're gonna, if the I is equal to the I plus 1, we want to keep incrementing I. Time complexity over here is O of n square, sorry, O of n cube. that works. And does it pass all the test cases? Yes, it does.